And we are live. So welcome SINUMERIK Nation to the Simply SINUMERIK Live Christmas Special. I am your host, Chris Pollock, and today we're going to have a little bit of fun. We're going to maybe learn a little bit a Christmas ornament. So we're going to be making the 20 Snowflake Ornament, and then at the end we're going to have a little bit of fun trying to take this more two-dimensional object and turn it into a three-dimensional shape. So for those of you that have checked out the description down below, you may have noticed there's a download link. So my little Christmas present to you, I gave you the part programs and the part print to be able to make this part. So you have it methodized in two different formats or ways. I know we all run our machines a little differently. So you have a conversational version made from shop mill, and that's what we're going to kind of go through today. But additionally, we have a G-code version that I posted out of our NX-CAM system. So if you don't use shop mill, or maybe you just prefer G-code over conversational, it's totally acceptable. There is a program there for you, so you can run it. There's a couple different strategies. I did a few different things between the two programs, so I'll talk about them as we get into it. So without further ado, why don't we dig in a little bit and start talking about how I set it up and what I did here for our Christmas 2020 ornament. So here you see we have the part set up in a basic lathe chuck. So this is something that I do quite common if I'm working on bar stock. I'm sure a lot of you guys do this, but maybe for some of you that's this is a little unique. What I do is I'll just try to find a plain back 3-jaw chuck that I have kicking around the shop, and that chuck allows me to, with a couple step clamps, clamp it right to the table, and with that I can easily fixture up round stock and hold a consistent center, and it gives me a little better clamping power certainly than my traditional Kurt style vise. So what we're going to do is we're going to find our center here on the part. So I'm working off the middle of the piece and the top, and basically what I'll do is I'll keep shifting the 0 down as we go, as we get into the part, as I make more pieces. Now I started making these ornaments, boy, I was just looking at an old one I did back in 2009. So I've been making these for quite a few years, and I originally started using round stock not only because it was obviously a little more appropriate to maybe the shape of the part, but what it allowed me to do as a quick and easy way to handle these types of shapes is I could put it on my lathe and I could part it off. So we're going to do something unique here. We're going to use a slitting saw to part off the part. We're also going to put a slot feature in this part. But if you don't have access to a slitting saw, you know, I actually haven't had one till just recently, then what you may want to do is you may want to move it before you get to those final operations over to a lathe, and you can just use a 62 thou wide grooving tool to slit your part or to part it off. Okay, so what am I doing? I'm coming in and I'm setting my part 0, specifically my Z-axis, to the top of my part. And what I'm doing is I'm shifting basically a 1/4 of an inch after each part, leaving myself 10 thou for a finish cut. The 0 is working from the center. A quick, easy way on the SINUMERIK control to find the center with a probe is you use our boss cycle, and this will come in, measure 4 points, and set the center location to whatever value I want, in my case 0. So what I'd like to do is I'd like to get this part running for us. We're going to let it run in the background a little bit. This way we can go through the programming. We use a piece of software we show quite often on this channel called SINUTrain while the machine is making the part. So we are going to navigate over to our part program. We're going to use the conversational version, and we'll go to execute that. Let's get this thing running, and we can dig into the part program. So no matter how many times I run these, I'm always cautious when I'm coming in for that first cut. I am going to run flood coolant here on this part. Okay, so what we're going to do is we're going to switch over to SINUTrain, and we're going to kind of go through and talk about some of the features within this part program. If you don't mind, I'm going to be a little lazy today. I'm going to grab myself a stool to sit down and get comfortable because we do have some programming ahead of us. So one of the first things I did, let me flip my microphone here, is obviously we're going to come in and we're going to face off the part. Now, as I mentioned, you do have a part print you can work from here. So when you download it, you're going to get a PDF file. You should be able to see that on the screen here, and it just gives you some base details. Now you notice that we haven't gone through with a lot of dimensional data here for each of the features, and primarily because we have some expanded out, but I've driven this part program from a Dxf file. So you guys are going to get a chance to see how we program from a Dxf file here. We're also going to use a option, kind of a unique function called Residual Material detection to figure out where my larger roughing tool couldn't fit. When I get into some of these branches, the radiuses are smaller than my 3/16 end mill. Did give you a full list of tooling and speeds and feeds, and certainly I welcome you to maybe even try to make this part program from scratch. So you also were provided the Dxf file that we're going to use to program our shape from, and this could obviously be brought into a CAM system if you would like, or you can drive it right here from the machine. Okay, so I have the full-blown part program right there, but we're going to kind of program it up on our own. So why don't we create a new part program? We're going to do a shop mill program, and I'll call this our Snowflake. Oh, guess I already have that one. We'll call it Snowflake 2. So we're going to come in, we're going to launch SINUTrain, and there's a couple things you may see that might look different than your system if you're used to SINUTrain. So if your machine doesn't have any rotary axes, or they didn't turn this on, you may not have this clamping option. But the clamping option is a nice feature. So if you have a machine with rotary tables, you will want to see if you can get this enabled on your machine. But what it does is it allows me to orient the workpiece blank either on my rotary or on my table. So my machine happens to have both a 4th axis table that I just removed for this job, but if I was doing this part on a 4th axis, I would have set this to table. Other than that, setup's pretty straightforward. I'm using a basic cylinder, 2.5-inch diameter stock, which is detailed in your part print. I left 10 thou for a facing cut. Overall, if you look at the stock, obviously it's larger than an inch. I just gave that for graphical representation. And then the rest of this is just, you know, where do I want to go when I'm done? How close do I wrap it to the part before I start cutting? Downcut, upcut is an important field. This is conventional milling or climb milling. And when we get to the slotting saw, we're going to talk a bit about that. Facing, super straightforward and easy. Just go over to milling. You have a face mill cycle. It will grab the basic geometry from the blank. Usually I just have to adjust my starting and ending positions, give it my appropriate tool. I'm using a 1/2-inch tool. And you notice in the Siemens control, I can drive tool changes from the name of the tool. Some speeds and feeds. So here I'm running a 2 thou chip load at 600 surface feet. Unfortunately, when I get to some of my smaller tools, I do limit myself on RPM, so I have to cut my surface footage down. So if we take a quick peek, you'll see we have our basic facing operation. Now after the facing, this is where it kind of gets interesting. So we have to machine out the contour of that part. So remember, I mentioned that I gave you back here a Dxf file. So that's your basic profile Dxf. So if you don't have the Dxf function, you can still view Dxf files at your control. Just like I showed you the PDF file you were looking at before. And you can even go into details if you want to go into maybe specifically check geometry of an element. I can pick different features through the part. So you can use this to get an idea of what the part looks like. But if you have the option for Dxf, then what you're also going to get is inside the program, where we're here, when I go to my contour milling and I use any of my contour functions, under new contour you get an import from Dxf. So for us, what we're going to do is we're going to use the spigot cycle, because spigot will allow me to machine from the outside in. I'll have a basic part boundary, and then I'll have the shape of my part. And what I want to do is I want to create these boundaries in a certain order of operations. So the first boundary is going to be my stock. So in my new contour, I'm just going to create a standard boundary. I'll just call mine stock. You can name it anything you want. And in here, I'm just going to create a basic 0. So in my case, I like to, if I'm doing a circle like this, I've said basic 0, a basic circle. If I'm doing a circle like this, I have a tendency to want to break it up into 2. Sometimes it builds a little easier. You certainly don't have to. So in my case now, I'm just giving it the 3 o'clock and the 9 o'clock positions. Center is 0, 0. I get half my circle. I'm going to finish up my arc. Direction has absolutely no bearing. I just out of habit will always think ply milling. So I have a tendency to always draw in that direction. But here is our stock. So that's super basic, super easy. Just save it. Now, how do I get in that much more detailed contour? So I'm going to create a new contour right after the stock, and this is going to represent the boss or the spigot. So we select new contour, and I pick import from DXF. Now I do have to give it a name, so I'll call it my Snowflake. Call it anything you want. It's just for your own recall. And now I'm going to browse to the DXF file. So workpieces, I put mine under my Christmas 2020, and I have the DXF file here. Now when you come into the Dxf Editor, now what you have to do is you have to select what parts of the DXF or the feature that you want to grab. Now there is a little trick here that you want to make sure you have set up properly. So if you go into details, there's a snap radius. Now by default it's 0.1. I know this says metric. We don't dynamically change that name. It is going to be specific to the unit of measure that the system's in. So for a metric part, 0.1 millimeters would probably be okay. On an inch part, that is a large value. So you could miss geometry. So if you're ever using the DXF converter and it's jumping over lines, it's probably that snap radius. Now once I do that, I want to select my automatic mode. This is another mode that's really handy. It'll auto chain the whole thing instead of me having to select all of my elements. Then pick select element, pick a feature, pick it twice, and you see, voila, I get an auto chain. If I didn't set it to automatic, then I would have had to pick each of the elements. So if I maybe only wanted a portion of the DXF, I could certainly do that as well. Once you've clicked on it and you got everything that you want in this orange color, just back up and hit accept contour, and what it's going to do, it's going to transfer it over into that same editor that I created the circle in. So I can not only see the geometry, but I can actually go through it as well. So if I accept it and we open up the snowflake, now you see every piece of the elements of my snowflake. If I wanted to, I could change radiuses, edit it right here. I'm not going to, I'm going to leave it alone. So now that I have my stock and my geometry or my contour, I can link it to my spigot cycle. Spigot is boss milling. So when I go into spigot, I'm going to pick maybe a roughing strategy, go select a tool. So I'm going to use my 3/16 end mill. We'll give it some speeds and feeds. Now remember, I only have an 8,000 RPM spindle on this machine. So if I put in my surface footage and toggle it back, it'll give me my calculated RPM. Same thing with my feed rate. So I want to be kind of, cautious of my speeds and feeds here. Certainly in aluminum like we're running now, I'd rather be up in the 600 surface footage range if I had the RPM. So I'm just going to cut things back a little bit. We're going to rough it out. Top of the part, total depth. Radial step over engagement. This could be a linear distance or a percentage of the cutter. We're going to do a percentage of the cutter. My depth per pass. So in my case, on the real part, I broke this up into 3 planes. Because when we get into between the branches, you're going to see it kind of has to zigzag in a little bit. With that zigzag, you end up with a much larger percentage of engagement, radial engagement, than the 20%. So I do have to go a little conservative. Certainly here inside a SINUTrain, for simplicity's sake, I'm going to take this all in one cut. How much material do I want to leave for a finished cut? We can save it. And now you're going to see it's going to start machining the profile of that shape. So we come in, we're going to quickly deck off the part. Now simulation is always going to want to start from the beginning. You can do some tricks if you want to kind of jump over some features for sure. What I'll do is I'll add a go-to statement in, I'll zoom back a little bit, go-to statement, and I can jump to either markers or end numbers if I want to. But certainly if I need that geometry to be there, then I would want to have it represented here. So now we're going to kind of just work around the part. It's going to machine in. And then after this pass, you're going to see it's going to start to dive into between the two branches of the snowflake. So the step over there you get it. So that first step over, that's the 20% of the cutter, but you see when it's coming through, obviously I have a much larger cut depth. So now she's going to start machining out the part. Looks like we have just caught up with the machine. That's great. So the next challenge, what the machine is working on right now, is these different radiuses. So when I designed the part, I used a 0.62 radius, figuring I could finish all this up with an 1/8 inch tool. However, when I look at how much material, if I was just to come in for a finish pass, it'd be a pretty heavy cut. So what you can use, if you have the option, is a function called Residual Material. So see this right here under pocketing and spigoting, any of our area clearing type of routines, you can have this option. And what Residual Material will do is it allows me to pick a new tool. Obviously I can define some new feeds and speeds, a percentage of engagement, depth per pass, and just by saving that, it's now going to look at the previous operation, figure out where the other one didn't cut, and then go in and cut those options. Now for me, I'm going to finish this up with that same 3/6 or 1/8 inch tool. We'll jump back to the 1/8 inch tool. A little trick, a lot of people don't realize, if the tool's already loaded, you don't actually have to fill it out inside a SINUTrain. You can leave it blank and it'll use whatever the last tool was. So I'm not going to worry about the speeds and feeds. They're all listed for you obviously on the part print. Top of the stock, bottom of the stock, we're going to do a finish of the wall. So I want to make sure I change that selection. Now the only thing that's unique when you get to finish, this trips guys up from time to time. This finish amount, you may think that it's going to leave that material on the wall. That's not the case. It's going to machine, since I'm telling it to finish, it's going to machine it right to size. However, what it is going to do is it's going to use this 5 thou as the ramp or the lead in amount. So you do have to have something here. If you zero it out, you'll notice the system tells you that it thinks it's rapiding into the part. If you want to induce a larger lead in, you can certainly put something even greater than the finish amount you had left on the previous operations. Now if we come over and we take a look at the part, and I'll jump between simulation in the editor here or sometimes in auto, depending on what I'm looking at. I find actually in SINUTrain, it can run a little faster when I simulate here in my auto mode or my real-time simulation. So now we're going to come in, we're going to clear out the part. Now this clearing section, if you download that NX file, that G-code file that I created, I did this a little differently. So on the machine and the program you're going to download is more like planar milling, right? So I'm taking in a few different planes. Through NX, I used an adaptive milling strategy. And what that allowed me to do is take the 3/16 tool, bring it to full depth, do a 10% radial engagement. I did use a little bit of chip thinning to boost my feed rate some because of my chip load is significantly reduced. And I machined this all out with an additive strategy. So if you haven't used additive and you want to play around with it a little bit, take down that program and take a look at how that works. Very cool type of tool path. Certainly in the right scenario can be faster than planar milling and also give you a little better tool life. Now you see these little loops on the part? That's where the residual material detected a significant amount of material left from the previous tool. And it's even bigger when you get into these radiuses. And then we came in, we cleared, and then we did a final profile pass all the way around the part. So that gets us basically to the point which the machine is at, right? So if I jump over to look at the machine here, we can see I'm just at a quick M0. Now we're going to do a tool change to our engraving tool. And if you've never had the option to use the engraving in the SINUMERIK control, it's a pretty cool feature. So what it allows us to do, and I can actually show you while we're here in this view, so you can get a little better close-up. In the program, in Engraving, we have a couple options here. So I'm going to come down and open up. I can do straight engraving. It can be mirrored or not. I can divide my start point. Now, you only get one type of font style in it, but what I can also do is I can do, and you're going to see in this secondary engraving, I can wrap things around an arc. So that is how I actually put in the text. So why don't we do that in our other example? All right. We'll let the machine do what it's doing for now. You can edit. You shouldn't edit the live program. It'll lock you from editing that, but I can do concurrent programming, so I could write new programs while the machine's running for sure. A lot of times I will use SINUTrain for that. I find it a little bit easier. So we're back over in SINUTrain. Let's go back into our part program, and we're going to add in our engraving. So this is going to engrave, and then it's going to drill the hole. In our case, we're just going to go over to milling, go into the engraving. We'll show you just the Merry Christmas at this point, give a couple different tricks. So the way it works here, obviously select the engraving tool. I used a drill mill, if you guys are familiar with drill mills. So basically it's a 1/4-inch end mill, but it's been ground with a 90-degree tip. I find they work pretty good for engraving. If you're too shallow, it will roll a bit of a burr. So I was conservative 2 thou. When you guys engrave yours, you may want to go a little deeper. I think I ended up on the physical part at 5 thou. From here, you can invert the text. So if you were doing like a mold cavity and you wanted everything to be mirrored, you could do that. I choose, is it straight? Is it wrapped around a radius, and which direction it is? Select a datum point here. Put in my text. You can support uppercase, lowercase. We have all sorts of special characters you can get to here. Or if you're getting into serial numberization, this is pretty cool. You can do date and time stamping. You can do a unique serial number, and it'll automatically index as it goes, as you run more serial production. So that's kind of a nice feature, very difficult to do on a program created externally. So a lot of times I'll use the engraving cycle, even if I'm programming from an external system. And then you give it some base dimensions. Now, when you're kind of doing this layout, you can bring up this graphic view, and it'll give you a little wireframe of what's going to go on the text. The other thing I like to do, oh, I didn't save it. Let's go back to engraving and save it. Is I'll also come down to end of program. A lot of people don't realize this. If you open up the end of program, it'll give you an overall wireframe of all of the operations currently on the part. So obviously I didn't do the 2020. We just have the Merry Christmas. But here I can see that there. Now the final operation, which the machine is just about to do, so we can cycle start it, is our slitting saw operation. And this is kind of a fun one. So what I did is I got myself a 4.5-inch diameter on my arbor size. I needed, get her going, we're into it. I needed at least a 4.5-inch diameter to be able to get all the way to 0 and not catch that center nut. Now you notice she does bark a little bit for sure. When I started getting into the slitting saw, I hadn't really run them on CNCs very often, so I did a little bit of research on it. And what I found was a lot of guys were saying that you have to conventional mill with them. And I think if you're using a non-keyed slitting saw, that's probably a good practice. Now you do want to make sure you set the direction of the teeth so it would load or want to tighten the nut that's holding it in place. That's logical, but I could still climb mill with it. And I found in this part, it actually cut much better climb milling than conventional milling. Now, how did I do the tool path? Well, I wanted to spiral in. I wanted to spiral in till I got to the center hub, and then later I wanted to spiral in till I did the full cutoff. So you can do that with our multi-edge spigot cycle. And you might think, oh, I must use the slotting routine because it's a slot. Well, the slotting routine is actually designed for more of a vertical tool where I'm doing like encapsulated slots or keyways, but not a circumferential slot around the peripheral, right, which is what we're doing. But what you can do is you can use the multi-edge spigot In most cases, people always think about having multiple flat sides here, but if you set the overall, where is it? The width and then the corner radius to create a circle, right? So I did 24 thou, leave myself a little hub in the middle to hold it, and then I did 12 thou to be the corner radiuses, right? It'll give you a round feature. And this will give us a nice continual spiral, so no hard step over, right? It's spiraling in all the way to whatever that minor diameter is. So the first one is cutting right now. I came into a 1-inch diameter, and then this last one, she's going to part off the whole part. Now there is a trick here. Out of the box, this cycle is generally set up to not accommodate a slitting saw. So that last move that it just did, if you were watching the machine, it rolled out and then rapid it up in Z. Normally she'll pull straight up because it's thinking you're using a vertical tool. So you do need to set an MD, and in the program I gave you, the shop mill program, I did give you a little note down here, 52214, this is a machine data, bit 2, I need to set this to a 1. That is what will allow the multi-edge cycles to do a unique strategy to clear the blade before it picks it up in Z. So this is very important. If you're going to run that program, you must set this machine MD. So how do I set 52214? Pretty easy. I'm just going to go menu select, setup. I want to go into my machine data area. Now it happens to be a channel MD. I know that from experience, but you could go searching through each of them if you wanted. So here I'm going to type in 52, what did I say, 215? No, I did not. I even forgot the number. Good thing I wrote it in the program. 52214. I was one off, isn't that figure? All right, so search 52214. Now this is what's called a hexadecimal. So I do need to double click on the field. I can also hit the select key to go in, find bit 2 and just check it on. Now when you do that and I say okay, this is what's called an immediate parameter. So I don't have to reboot the system or anything for it. I can just set that value and then I am good to go. So when we come back and we take a look at the program, so we can add this to maybe our final snowflake. Oh, why don't we go into our snowflake 2 and maybe I'll set it up. I happen to have the numbers there from the part off operation, so we'll accept it. So if we go over and we do a final run, and we're going to rewind, I want to run it right from the beginning. We'll show the whole program, minus a little extra engraving, and certainly we didn't add the drilling routine, but that is in there, and I'm confident that you guys know how to use our drilling cycles. So we'll peripheral mill, and once we do that, we'll do the residual material. I did do a residual material technique with NX as well, so you'll see that if you run the NX. Looks like we're just finishing up. I can hear the final cut. And if you watch the machine view, you'll see we spin out. Maybe one more pass. Nope, there it is. Spins out, retracts up, shuts off. These part-off blades like a lot of coolant, I will tell you that. I did have one go on me, and I think it was because I was a little shy on the coolant. So here you can see we're coming in, and I was actually conventional milling when I lost the one. So it's going to spiral all the way in. So there's our tool path, and then you'll see when we get to the bottom, it does this sweep back to the start point. And with that being said, we have a finished snowflake, just about. So what do we want to do is we want to come in. I'm just going to jog my machine out of the way a little bit. So you see how it kind of just wobbles? I think you guys can see that, right? Probably. So it's just caught on by that little boss I left, so we can just kind of spin it and twist it off. This way it doesn't shoot it across the machine. It leaves a little bit of a tip there. Also, it may leave a little tip on the raw stock. So when I probe, I don't know if you noticed before, I probed just off a center for my Z because I didn't want that tip to affect coming off. I wanted to hit this final plane. So we have our ornament. It is not only cut off, but you'll see there is a slit down the center. So our final ornament, we want to do something with a little bit more three-dimensional geometry. So when I was thinking about this, I said, well, I got a scale. Why don't I just take the scale, slide it in here. What I like to do is put my thumb, so it's going to end up right really the base where the base of this branch is. And then it's up to you. So this is kind of a make your own project. You can flex or bend this out as far as you want. When I had originally designed it in NX, I think I was working around a 20-degree angle. So we can come into each of these tangs and then just work yourself right around the object. So like I said, I've done quite a few of these ornaments over the years. I've done Christmas trees and snowmen, and a lot of times I like to use Lexan. That makes a really cool effect. I've done candy canes out of Lexan, and then you can machine just shallow grooves in the Lexan part, and you can give it some different depth. So you can have part of it be see-through and part of it be opaque from the machining. So Lexan or plexiglass, any of that stuff works about the same. So work yourself right around. It's aluminum, so it's pretty ductile, right? You can bend it. I wouldn't go crazy bending it super far. You don't want to break off a tang. But here we go. So I hope you guys have enjoyed. I hope you like, oh, looks like we have some visitors here before we end. Come in, come in. So I have a couple holiday elves here. These are my two daughters. You wanted to wish everybody a Merry Christmas. So wish my SINUMERIK Nation, say hello to the SINUMERIK Nation.
Hi.
This is Chloe on my right and Emma right in front of me. These are the two girls that did such a great job decorating our machine. So thank you for stopping in and saying hi to my friends out there in YouTube land. And with that being said, I want to wish everybody a Merry Christmas, a Happy Hanukkah, Happy Kwanzaa, certainly happy holidays to all. Stay safe and healthy, and I look forward to seeing everybody next year. So with that said, have a great Christmas season, and we'll see you guys next time. Thanks, girls.